In this video, you will learn to multiply polynomials. I would recommend that you take notes in your notebook or watch this video to recap what you've learned in class if you've already learned how to do this. Let's refresh our memory on what we've learned already this year. In this first example, we have 3x times 2x squared. We know that this is really 3 times x times 2 times x times x. We can multiply our 3 and 2 coefficients together to get 6. And we can multiply our x times x times x to write x to the third. So we get 6x to the third. In the second example, I have 2x to the third times parentheses x plus 4, or times the sum of x plus 4. Because I see addition in the parentheses, I know that I'm going to have to distribute this whole term on the outside, my 2x to the third, to each term on the inside of the parentheses. So when I distribute my 2x to the third to my x, I get 2x to the third times x, which is 2x to the fourth. Then when I distribute the 2x to the third to my 4, I have 2x to the third times 4. In other words, 8x to the third. There's a plus sign between these because both of them are positive, and I know that I was adding the two terms. Since my x has an exponent of 4 on it over here, and my x has an exponent of 3 over here, they're not like terms, so I cannot combine them any further. So far, this is all review. Now let's look at what happens when we're multiplying a binomial times another binomial. Remember that a binomial is an expression with two terms. Let's start with the most basic example, x plus 2 times x plus 3. Notice that this whole first binomial is in parentheses. That means that this whole binomial is being multiplied to this whole binomial. In other words, every term in the first expression must be distributed to every term in the second expression. And I'll show you two ways to do that. The first is our usual arrow method. I multiplied x times x to give me x squared, and x times 3 to give me x to the third. 3x. So I get 2x from 2 times x, and I get 6 for 2 times 3. My final step is to combine my like terms. My only like terms here are 3x and 2x because they both have x to the power of 1. So my final expression is x squared plus 5x plus 6. Another way to set up the same problem is to use the box method. A lot of students find that this helps them visualize what's happening. So I wrote my first binomial, x plus 2, along the top, my second, x plus 3, along the side. In each box, I'll write the products. So I have x times x gives me x squared. 2 times x gives me 2x. X times 3 gives me 3x. And 2 times 3 gives me 6. Now I can write my final answer, again, by combining like terms, and I should get the same expression as I got using the other method. Let's look at another example where we have to be a little bit more careful of signs. We have negative 2x plus 3, and that whole quantity is being multiplied by x minus 4. I'm going to go through this one a little bit faster. So if I have my term negative 2x and I'm distributing that, I have negative 2x times x gives me negative 2x squared. Then I have negative 2x times negative 4 gives me a positive 8x. Now I need to distribute the 3. 3 times x gives me 3x, and 3 times negative 4 gives me negative 12. Last step, as usual, is to combine the like terms and make sure we've written it in the proper order. So I have negative 2x squared plus 11x minus 12. I know that I've written it in the proper order, or standard form, because my leading term here has the highest degree, the highest exponent on my x. I have a degree of 2, then a degree of 1, then a degree of 0. So my leading term is negative 2x squared. My leading coefficient is negative 2. I've set up the box method as well. Notice that because I had a minus 4 over here, I wrote negative 4 on the outside of my box. The signs are the most important thing to keep track of here. I'll fill it out. When I fill it out and am careful of my signs, I get the same expression, negative 2x squared plus 11x minus 12. If we're multiplying larger polynomials, in this case I have a binomial times a trinomial, I'll use the same method. I'm not going to do this problem out for you though. I can either use the arrow method, where I'd have the arrows going from each term in the first set of parentheses to each term in the second set of parentheses, or you can again make a box. So in this case, we could either make a 2 by 3 or a 3 by 2. Either will work. If you decided to do this out, you would have gotten 2x to the third minus 5x plus 6, just for those of you that wanted to do it to check to make sure you're doing it correctly. Caution. Remember that we only distribute if we see addition or subtraction in the parentheses, and a term or more than one term on the outside of that parentheses. So in these 4 examples, I know that I would not distribute in the first one because I don't see any plus or minus in the parentheses. In the second one, I have 3x times 2 plus x, so I need to distribute the 3x to everything inside. In the third one, I have 3 plus x, but those are not in parentheses, and so the only thing that gets distributed into the parentheses is my x. Now, in the fourth one, since there are parentheses, I'm multiplying this whole first binomial to the 2 plus x. So therefore, it will have a different answer than number 3. I'll write out these answers just so if you were curious, you could check your own. And I've also rewritten them all in standard form if they were not in standard form to begin with. My final thought that I'll leave you with is if you see something like this, x plus 3 squared. When we did the exponent unit, I told you that if you see a plus or minus inside, you cannot apply this exponent into each term the way that you would if it were multiplication inside. I want you to think about what this means and figure out how we would simplify this expression. And what you should get is x squared plus 6x plus 9. So you need to figure out how I got this.